Okay, let us do some calculations. We took one data set for there was 8 washers plus the alligator clip, 61.971 grams on the weight that was providing the tension. The bob was 12.095 grams. So, and we timed we timed it. So these are the times it took for 10 oscillations. So the first thing you should have already done is average them out. And what's the average? I got 2.99 seconds. Now to find the period, you can divide that by 3. So it's 10. I did it for 10 oscillations. And again, that was pretty tricky. You can see there's a little bit of variation on there. That's why we took more than one measurement. Ideally, you take like 10, 20, hundreds, whatever. You get a much better value. So what we want, if you remember, you don't remember, but let me write down the equation in the book that we were looking at. So the tension in the string is providing the centripetal acceleration. That's the mass of the washers and everything else, times G. We're going to compare that with the centripetal force, which is the mass of the bob. So that's the cork, whatever you call it, bobber, corker. It looks like one of those things that fishermen use, so I call it a bob. It's not really a bob, I guess. And 4 pi squared times the frequency squared times the radius. So that's the value for centripetal force. This is centripetal acceleration. F equals ma. So to find the force, you multiply the mass of the bob times the centripetal acceleration. And again, I put this is the form that has the frequency, not the period in it. You just so that, it's all in one line. I guess you could put the period squared underneath if you want to. And that should be pretty close to what the tension of the string is. I mean, they should ideally be equal to each other, but. So first of all, what's the tension of the string? Well, the mass of the washers and everything on it was 61.971 grams. So what's that? 0.061971 kilograms. You multiply that by 9.8. And what do you get for the tension? So do that now, 0.061971 times 9.8. So 0.607 newtons. I guess it's a little less than a newton. So now let's compare that with the value we get for the centripetal force, or experimental value. So there's a theoretical value, what it should be. So let's see how close we get with the experimental value. So for the frequency, what you want to do is, well, we haven't calculated yet, have we? So let's go back here. All we have is the period. The frequency is 1 over the period. So the frequency is 1 divided by 0.299 seconds. So 1 divided by 0.299 seconds. It's about 3.34 hertz. And again, the units are either 1 over seconds or hertz. Hertz is the standard way of saying frequency, a regular frequency, not angular frequency. But normal frequency is in hertz. Angular frequency would be in radians per second, and there's a 2 pi difference. Okay, so that's a frequency F. So what does this mean? It means a little over 3 times a second the bob went around. So the bob was going around a little over 3 times per second. That's what the frequency means. Each rotation takes 0.299 seconds. That's the period. It goes around a little over 3 times per second. So that's an inverse relationship. So now we know what to put in F. We're going to put 3.34 hertz, or 1 over seconds in there. R is the radius, and for the first trial we had 0.10 meters, right? Approximately. So and mass of the bob, that was the 0.01209. I think that was a 5 on the end. I can't read my writing, so plug them all in and get the value. Then you can compare it with the tension. So we got the tension to be 0.607 newtons. See how close you can get with the experimental value, and then you take the percent difference between the two of them. okay? So go ahead and calculate that out and do the same calculations for all of them. The only thing you're changing is the frequency and the radius for each, and then, because for this particular exercise 1, we're going to keep the mass the same for the whole thing. I'm not going to add or subtract any washers. For exercise 2, I'm going to change the weight. But for exercise 1, we're going to, the weight will remain the same. So the only thing you have to redo is this each time